Okay, so we're going to look at another capital budgeting model, and this one is known as the net present value. So let's look at a capital budgeting model that considers the time value of cash flows, because that's been one of the criticisms of the payback period as well as the accounting rate of return. And what does it mean that it considers the time value of cash flows? Well, think about if you had a dollar today and you invested that dollar, you would have, by the end of the year, you would have more than a dollar. So the value of having the money today, you have an advantage because you can take that money and you can invest it. So money that you receive in the future, there's a disadvantage because you did not have the opportunity to take the money and invest it. So therefore, we want, when we're looking at these capital budgeting models, we want to account for when do we receive the cash, and that is included in the net present value. So two basic calculations that we'll do in the net present value. We're going to discount the future cash flows from the investment at the required rate of return, and that's also known as the hurdle rate. So step one, we're going to discount the future net cash flows from the investment at the required rate of return. And then two, we're going to subtract the initial amount invested from some of the discounted cash flows. And we'll do an example so you'll see this. In fact, we're going to take the same example, Fast Track. So Fast Track is considering the purchase of a conveyor costing $16,000 with an 8-year useful life with zero salvage value. Okay, so all of that is consistent as in the past. And it promises annual net cash flows of $4,100. Fast Track requires a 12% compounded annual return on its investment. That is the hurdle rate. Okay. So here's the net present value with even cash flows. So let's look at this table. We have up here, we have the year. So we have year 1 through 8, just like we did previously. And then we have the annual net cash flows. It's about 4,100 every single year. Okay, and then we have the present value of 1. And we'll go into what this present value of 1 factor is. And then we calculate the present value of cash flows. How do we do that? We take the 4,100 in year 1, multiply it by the present value of 1 factor rate, and that is equal to then 3,661. Okay, and then we take the sum of all of our cash flows, and that's 20,000 by the end of year 8. And we say, well, how much did we invest? Well, we invested 16,000, and so the net present value of our investment is greater than what we put in, so that would be 4,367, and that's a positive. Okay, so let me first go back to our present value of 1 factor. You can look at your appendix, or you can simply go online and get a factor table. But let's think about what this tells us. If I have a dollar, and that dollar, if someone gives me that dollar today, then I have the ability to take it and invest it, right? But if I get it, every year that I wait to get that dollar, the longer I wait, what happens? You'll notice the value of it, even though every year it's 4,100, the value of it decreases. Why? Because you were not given that opportunity to take the money and invest it. Okay, so the present value of a dollar is greater today than it is tomorrow. Okay, so let's take a look at a present value table. So I went online and I downloaded a present value table. So let's look at this present value table. So you have the periods here in the first column, and we're looking at 8 years. So those are our 8 periods. And our hurdle rate, or rate of return, is 12%. So this is the 12%. And you'll notice for year 1, it's 0.8929. For year 2, it's 0.7927, and so on, just like we have in our table. Okay, so let's go back. Okay, so this is what we have. the present value factors of 12%. We just went through the table, and as I said earlier, a positive net present value indicates that this project earns more than 12% on the investment. Okay, so how do you make your decision? Well, the net present value decision rule is when an asset's expected cash flows are discounted at the required rate and yield a positive net present value, then the asset should be acquired. So we take the present value of the net cash flows, okay, we subtract it from our initial investment, and that was about $16,000, and we look at what is our net present value, and we noted that was greater than zero, and so if that's the case, then we go ahead and accept the project. But when it's less than zero, so that means we haven't recovered what we've invested, okay, and we haven't recovered our hurdle rate as well, so then we would reject the project. Okay, so that is the net present value. The general decision rule using net present value. If the net present value is positive, okay, whoopsie. If the net present value is positive, then it's generally acceptable. Why? Because it promises a return greater than the required rate of return. If it's zero, it may be acceptable since it promises a return equal to the required rate of return. Okay, so that's kind of like your break even. It meets the minimum threshold. Now, if it's negative, it's not acceptable since it promises a return less than the required rate of return. So that's generally the decision rule that you would use when looking at net present value. Now, let's quickly look at net present value calculations with uneven cash flows. So we have here year 1, 2, and 3, and we have net cash flows for Project A, Project B, and Project C. So Project A shows if we receive the same amount of net cash flows, and remember net cash flows is simply cash inflows minus cash outflows, the same amount every year. Now, Project B, you receive more money in year 1, a little bit less in year 2, and a lot less in year 3. And for Project C, you receive very little year 1, a little bit more year 2, and a lot more in year 3. But look at the totals that you receive in all 3 projects. It's exactly the same. Okay? So they're exactly the same in total, but the amount that you receive every year differs. So let's consider the present value of $1, and we'll look at it for 10%. So you can go back to your table and take a look for 3 periods at return of 10%. So if you take 5,000, multiply it by 0.9091, you'll get 4,546. If you take 8,000 divided by 0.9091, you'll get 7,273. And finally, if you take 1,000, multiply it by 0.9091, you get $909. Okay? So that's how we get these present values of the net cash flows. So if I add them all up, what you'll see is, and we know the amount invested is the same for each of these projects. For Project A, the present value of the net cash flows is about 12,435. For Project B, it's 12,908, and Project C, it's 11,803. So they're all very different. Now, let's think about the logic of this. The reason Project B has a higher present value of cash flows is you receive the money from that project much, much earlier. So what's the advantage of receiving the money earlier? Well, when you receive this $8,000 earlier, you can take it and invest it. Okay? Therefore, the present value of this is much higher. And so you've got, as you can see, 7,000 the first year versus for the other 2 projects a lot less. And then if you look at for Project C, that's really has the lowest present value of net cash flows. And why is that? The reason it has the lowest amount is simply because you're receiving 1,000 in year one, 5,000, a little bit more in year two, and then a lot more in year three. But because you've received such a small amount the first year, that really contributes to what your present value of cash flow is. And then B and C is so different, then A would fall somewhere in between, and it does. Look at the numbers. For B, that's the best project, 12,908. 12,435 for project A falls right in the middle, and the lowest is 11,803. And so that kind of meets your expectations of what you think would have happened. So although all projects require the same investment and have the same total net cash flows, Project B has a higher net present value. Why? Because of a larger net cash flow in year one. So that's a way to look at an analysis when you have an uneven cash flow for net present value.